So we already know from our calculator that it could go in there at least 9 times. I know there's at least about 9 feet in that 109 inches. So then you could figure out 9 times 12 is your 108, like we talked about above, which is 1 left. So what this means, your remainder would represent like that smaller measurement. So it would kind of be like the 1. I know I put inches like it's plural, like if there were 2 or 3 or something, but you'd have 1 inch left over. So if we were converting this, I know my recording kind of started partway through that problem, but if we were converting this would be like the big measurement, 9 feet, and your remainder would be the inches part, 1 inch. So there are times that you do need to show your measurements as 2 separate units. And as you're doing the application process, you do that actually kind of a lot. And like I said, there's 2 ways that you can do this. You could start out with converting everything to inches and make it all inches, like 9, or I guess that's when we get here. But this is when we're taking all the inches and we would like convert it back into having 2 measurements of feet and inches to kind of break it up and make sense. Because in our minds, don't we kind of get a better idea of what 9 feet is rather than 108 inches or 109 inches is? Like we can already kind of in our mind think of that. I mean, we all know maybe a 6 foot person, add 3 feet on top of that one, right? Or something like that. Just some things that we can kind of compare it to give us an idea of what 9 feet would be. Not exact, but just in our mind. So yeah, I did like a part A and a part B with that number 1, just to kind of show you, you know, sometimes it'll tell you to convert something to feet and inches, but it could be just be a total 9 feet. Maybe there weren't any inches left over. And that would be, if you plug it into your calculator, you're going to see there's like no decimal number. So that's just an even number answer. But when you do it like this, and you would have seen that decimal does not represent the actual inches. So you really need to kind of show it in long division to help you find that smaller measurement that's left over. Okay. But then we're adding some feet and inches together. Sometimes you're going to be required to regroup it a little bit. And I'll show you what I mean once we do it. So first we can just treat it like any addition problem. Except for I do kind of work these left to right rather than right to left, you know, like you do in subtraction or something. But it doesn't matter if you work right to left or not. Just kind of look at your problem and we're adding. What's 7 plus 8? 15 inches. So you could go ahead and add those units together if you will, if you'd like. And then 6 plus 3 is 9 feet. But the thing is about this one, we may need to regroup because within this, is there a foot within that 15 inches? So we need to regroup that. Let's go like this. So we need to regroup it and add whatever whole foot you have in there to the feet and then figure out how many inches you'd have left over. So how would we do that? Do we just divide by 12? So I know many of you might not even be setting it up like that. I think we talked about that in our last lecture. It's okay. You know, you're just dividing by 12 because you know there's 12 inches in a foot. And I know 12 can go in there at least 1 whole time. So that means there's 1 whole foot within that 15 inches. And then if we take 1 times 12 and subtract, that tells me how many are left over, which would represent the inches that's left over. So this is really like saying I need to add a foot to that, and then I just have 3 inches left over. So you'll have to regroup it and add that bigger measurement back to it. And so that'd be like saying 10 and 3 inches, 10 feet and 3 inches. So you have some questions that are really just doing that. It's not even application problems on the homework, but you're just practicing adding them. And what you can do if you want, an application problem is you could turn all of this into inches if you want by taking 6 times 12 and adding 7 to it. And then that would represent that in all inches. 3 times 12 and add 8 to it. And you may see that when we do an application problem, or you can just keep it just like this and regroup. Sometimes we don't like choices, right? Like, tell me how to do it one way. But everybody's brains work a little bit differently. So I am showing you this way. But when you subtract, can I subtract 2 from 1 foot? No, so we're gonna have to regroup in the beginning of it. So it's like we borrow a yard and convert it to feet first. So we need to regroup first. How many how many feet are in a yard? Do you guys remember? Right, there's 3 feet equal 1 yard. And you can always refer to your little sheet. You don't have to memorize that. There's a sheet that's provided to you to refer to. So if I borrow a yard, I'm going to say, I'm only going to call this 6 yards. So I borrowed 1 yard and I want to convert it to feet. That means I have 3 feet to add to my feet column, right? Does that make sense? So instead of it being 1 foot, I'm going to add 3 feet from it because I am taking a yard away. So this would really be like saying 1 plus 3. I like to write it up here and rewrite my feet. So I have 4 feet and 2 feet. So I converted that. So it looks like this now. I added 3 feet to the 1, so I can subtract. So what's 4 minus 2? 2 feet. And then I can subtract 6 minus 2 is 4 yards. And so you shouldn't be converting in the end when you're subtracting if you had to borrow. Well, either way, you really shouldn't have to convert in the end when you're subtracting. You may have to convert, like regroup in the end when you're adding. But when you're subtracting, you may have to regroup to borrow from it in the very beginning step. If this would have been a bigger number than that, you wouldn't have had to do that, right? You could have just simply subtract and you're done. You guys have any questions about that? We're going to do it again. And well, let's go look at this next one. So this next one kind of goes to our capacity type problems. Do you guys remember how many ounces are in a pound? 16, right? So it's good to just kind of write 16 ounces equal 1 pound or the other way around, just so that you remember somewhere from that. So you can write this as I'm converting ounces to pounds and ounces. You could do what we did above. We could say 143 ounces times our pounds over ounces. So what are we doing? We'd be dividing by 16 basically, right? So I'll go ahead and do it like we did from the lecture the other day and show that we're going to be dividing, but you're probably going to see a decimal or a fraction. Oops, if I can turn it on. So 143 divided by 16. And it looks like just a fraction, or you might have turned it into a decimal. And so we can tell that there's going to be at least 8 whole pounds and some ounces left over, right? But remember, the 0.93 doesn't represent the ounces amount. So this is where you really need to write long division, 143 divided by 16. So it helps you get straight to the right whole number part. The 8 would be the whole number part. So let's take 8 times 16. So 8 times 16 is 128. And then we subtract. Remember, you wouldn't want more than 16 to be the difference, right? But if you're using that decimal number, you'll find the right whole number anyways. So 15 represents what? The ounces. And then the 8 represents the pounds, the bigger measurement. Okay, so what's left over is the smaller measurement, or maybe the one that you started with. I guess you could think of it like that. So this one would be 8 pounds and 15 ounces. 1 more ounce and it would have been a full 9 pounds, right? So there are times that you're not just converting to one single unit. that you can represent it as two partial units rather than like a mixed number, which we've done before. Like we might have said 8 and 15 over 16 ounces. Well, we're not going to do that. If we did a mixed number, we're going to represent it as 15 ounces. That mixed number part would be what's a little bit different with this part of the concepts you're learning here. Okay, let's turn the page and we're pounds and ounces again. So I could just add my ounces together, which is 7 ounces. And 2 plus 3 pounds is 5 pounds. Do I need to regroup anything? No, and the way that we know that is we said that there are how many ounces in a pound? Right, 16 ounces in a pound. So since that's less than 16, it's not like I have to regroup that and add a pound back to the pound spot because there's not a full pound right here. If that was 17 ounces, wouldn't we have to do that? Yeah, we'd have to say, okay, there's a pound within this with 1 ounce left over. So you'd have to regroup it and change that. Okay, but here we're subtracting pounds and ounces. Remember, I keep writing it 16 pounds in 1 ounce. My pounds got really funky, but pretend that says pounds. Can I subtract 14 from 7? No, so this number on top has to be bigger. So I need to borrow a pound and convert a pound's worth into ounces. So this is really 8 pounds. And I am borrowing 16 from it. So I will add these two together and I like to make a new column. So 16 plus 7 is what? 23 ounces. So I converted that into 23 ounces and then I can subtract my 14. So 23 minus 14 is 9 ounces. And then I can take my pounds and subtract them. 8 minus 3 is 5 pounds. So we had to regroup in the beginning to be able to subtract. The top measurement is a bigger measurement. It's just that the way that the ounces and the pounds were distributed, I couldn't subtract my ounces from those ounces. I had to borrow a pound worth of ounces, which was 16 of them. 16 ounces. And if you see one like number 7, you really can just type that into your calculator. I just wanted to remind you that you can do that. You don't have to convert and work with the mixed number. I almost didn't write this down, but I just wanted to, as a moment, remind you that you have been doing this since Unit 1. We don't do it a lot. We do it very randomly. But 9 3/8 minus 4 5 over 6. And those are all already pounds. And it will kind of look like an improper fraction to begin with. So just to remind you how to turn that back into a mixed number, since it started into a mixed number, you would click your second. And the button beside your fraction key turns that into... hit enter, turns that into the mixed number. So 4 13 over 24 pounds. Please remember in WebAssign, I think I've said this the last lecture, but I will say it again and again, is, if your problem doesn't give rounding instructions, even if you would have done this and turned that into a decimal and you tried to round because you decided what the rounding place was, it's going to be wrong. So you have to answer it in an improper fraction, or the mixed number would be most appropriate since it was given to you in the mixed number. If you were doing that manually, you would have either turned it into an improper fraction first, found a common denominator, then maybe converted it, a lot of steps. So that's why, I don't necessarily, you can do that manually if you want, but you just type in your calculator. Or you could just convert these to have the same denominator as well. You don't have to always turn it into an improper fraction. But calculator is, man, since you're doing application problems, it's just going to be a little bit quicker in some of those calculations. Okay, so now we're doing some pints and quarts and stuff like that and gallons. Do you remember how many pints are in a quart? 2 pints equal 1 quart. So that comes from that formula sheet. So definitely take a look at that. If you forget. So what are we dividing by then? Technically. 2, because if we're saying 1 quart over 2 pints, it's like we're just dividing 17 over 2. Right? So in your calculator, it's going to make it probably look like a decimal in the end. If you do that. But remember that 5 doesn't represent how many pints there are, right? It's just representing that there's a half of something happening. So don't get confused about that. Decimal doesn't translate to the smaller unit. So you would think about taking 17 divided by 2. And I know it goes in there at least 8 times. So that means we have 8 quarts, the bigger measurement, right? 8 quarts. And then 8 times 2 is 16. So whatever's left over is our pints, the smaller measurement, the leftover. So 8 quarts and 1 pint. Okay, let's look at number 9. It's really just repeating just with different measurements, and I think it's okay to kind of do it a few times. But 2 and 3 make 5 quarts, and 4 and 2 make 6 gallons. So we're adding quarts and gallons. Do you remember that 4 quarts make a gallon? 4 quarts make a gallon. So is there a gallon within those 5 quarts? Mm-hmm. Yeah, so this is where in the end we have to regroup this. We have to say, you could probably do it without doing this long division, but just kind of keep doing it the same way to be consistent. There's 4 quarts making 1 whole gallon within that. And 1 times 4 is 4. And then what's left over is our quart. So we have to add the 1 gallon right here, and then we would just have 1 quart left over because we converted that right here, and we regrouped this 5 quarts to say, well, we actually have 7 gallons with 1 quart left over. Okay, let's turn the page. So if we're subtracting, sometimes you have to regroup in the beginning to be able to borrow. You regroup to borrow, because I cannot subtract 2 from 1, and you can't go the other direction either. So we have to say, I'm going to borrow a gallon's worth of quarts, which is how many? 4 quarts. That looks like it. That was a, I'm going to borrow a gallon's worth. So really I just have 6 gallons now, and I'm going to create that or make 4 quarts in the quart section right here so that we can call that 5 quarts. So I can subtract 2 from it. So 5 minus 2 is 3 quarts. And then we can say 6 minus 5 is 1 gallon. So just kind of 10 examples there. Looks like I was going to do another one and thought that was enough. To kind of help you with the measurements, sometimes we do use them as 2 separate units. That is a way to do it, and it's okay to do it just like that. There are times where I might just, in my mind, think it's easier to convert it all to inches first, and then do it and then reconvert it back. in the end. So just kind of depends on how your mind works when you use this in application and maybe when you don't. There are still some people writing, so once you're done, we'll turn and we'll go to the application problems that we skipped over last class period in the notes. Okay, so reminder, this will always be given to you. You know, you don't have to memorize those things if you forget. It's already given to you. And that's how we make those rates or those unit multipliers. So we learned how to do some conversions by using those unit multipliers. Like I said, I'm really okay with, if you know, just to divide by 12, that's fine. The only thing that I really think is super helpful about using unit multipliers is maybe you have in-between measurements and you may need to multiply and divide or whatever. And if you set it up like this, it really just takes you straight through. And so, you know, you just need to be sure, like, I don't know how many yards, you know, are in a mile exactly, right? So we have to maybe convert that to feet. So then we can convert it to miles because I have a conversion between feet and miles, basically. So really it kind of helps if you find those and you're either working your way down or you're going to be working your way up, and that can help guide you through how to set that up. The big thing that I think that helps is just remembering you're starting with this and you're ending with miles. So make sure miles is in the top, and then try to make sure you have your diagonals that are going to cancel, and that can kind of help you pick out the right unit multipliers too if you're unsure. And it just takes practice, really, doing it more often, which, you know, we don't always do in our everyday life. Some of us do, depending on what your job is. But let's take a look at some application problems. It says the average of a player in the NBA is 6 feet, 6.98 inches. That's really like super technical, apparently. Find the average height in inches of a player in the NBA. So what I would do first is figure out like total inches. And so, or that's what we're doing, but his height in the beginning is in 2 different units. So we really need to convert the 6 feet into inches, don't we? We need to say, I know there's 12 inches in a foot. This would be like that unit multiplier if you set it up like that. You probably knew if I just take 6 times 12, that's going to convert this part into inches. So 6 times 12 is 72. And they already have an inches measurement. So we're going to say plus 6.98 inches. So apparently they are using some decimals in there to represent, I don't know, smaller measurement than an inch. So when we add that, that tells us the total height of the NBA player would be 78.98 inches. So that's kind of working backwards in some of those problems that we did in the extra notes. We did convert 2 units to just represent 1 full unit. Inches only. Number 2 says, how long must a board be if 4 pieces each? How long must a board be if you can cut it into 4 equal pieces? Each piece is 3 feet, 4 inches. So we're going to answer 2 things. It's going to say how many inches is that? How many feet would that be? But remember, there's 4. How long must a board be if you can cut it into 4 equal pieces? Each piece that you're going to cut, though, is 3 feet, 4 inches. So they want to know what's the big board before you start cutting those pieces. Kind of reads a little bit weird. So first we need to turn this into total inches, right? So we're gonna say 3 feet times what? 12. So you could just start doing it like that, or, that's what we're doing here, would be 36 inches, and then we can add our 4 to it. So each of these boards are really 40 inches, but we want 4 pieces of this. How do we find how many? Yeah, if we want 4 of those, we would take that 40 inches times 4, because we're going to have 4 of these sections. So if we're measuring this one single board that we're going to cut from, then it would need to be 160 inches if we measure that and represent it in inches. But then it says, how many feet would that be? So what do we do to convert that to feet? Right, we would just take that 160 inches, and technically you're dividing by 12, or if you are still doing this, which is just probably what we should show, that shows that you're just dividing it by 12. Now this is going to represent either a decimal. It's not a whole number. So since it says in feet and they don't give us rounding instructions, how would I answer that? There's no rounding instructions and they only tell us feet. They don't tell us to say feet and inches. Maybe turn it to a mixed number, right? Or you could, I guess, answer it as an improper fraction. I know that would be a very weird way of answering something in application purposes, but remember, this is where you go second and hit that button beside your fraction key, and we would say it'd be like 13 1/3 of a foot board. This would be a case where, like, you just need to know about how many feet. Probably a board is not going to come in 13 1/3 worth. It's going to come in like, I don't know, 16, 20 feet. I don't generally buy a whole lot of lumber, so I'm not sure, but it's going to be longer than that, like 13 and apart. Okay, number 3, a roof is constructed with 9 rafters. Each are 8 feet 4 inches long. Find the total number of feet of material needed to build the rafters. So we need to go ahead and convert our feet into, because it says find the total number of feet material needed to build the rafters. There's 9 of them. And each rafter is this. So what do you think what we'll do? Well, first we need 9 of these, right? So you could turn it into inches if you want and multiply times 9. Or we could just multiply each of these units by 9, right? Because you got to have 9 8 feet worth and 9 4 feet worth. Which one do you guys want to do? We'll let you choose. 2 ways. Let's just take it and say, I know I need 8 of these. So 8 feet and 4 inches. And I know I need 9 of these. I think I said 8 because of the feet part. I know I need 9 of those pieces of rafters or pieces of material to build the rafter. So I'm going to take it times 9 because I have 9 of them, but I'm going to do both of those times 9. Let's do it like that. So 8 times 9 is 72 feet. 4 times 9 is 36 inches. So what do you think we would need to do now if we're going to talk about, we just need to know how many feet of material do we need? Right now we're showing feet and inches, and this looks kind of weird. 36 inches, isn't there more than a foot within that? Mm-hmm. So we need to convert this. We need to be like, well, how many feet are within, or how many feet are within our inches? So I'm really just dividing by 12, right? And that happens to be an even amount of feet. We won't have any inches left over. So 3 feet. So if it says find the total number of feet needed, what would I do? Just add these two things together, because really we're saying this was 36 inches, but actually that's 3 feet. So I would just say 72 feet plus 3 feet, because I converted it, means I need 75 feet worth of materials to make these, this roof, these rafters for this roof. If you would have converted it into inches, in the end, you would have had to divide it by 12, right? To convert it back to feet. So that's why I said, like, there's a little bit of freedom sometimes to work with it how you like. I try to do what I think is easiest for you guys. Number 4, a case of 24 cans, each weighs 6 ounces. Find the weight of the case in pounds. So if you had a case of 24 cans, and each of them weighs 6 ounces, we can find out how much it weighs in ounces first, and then convert into pounds, couldn't we? By just multiplying. So this would be the total weight in ounces. So 24 times 6 is 144. But this is representing in ounces, so we just need to convert in the end to pounds. So 144 ounces. And we know that there are 16 ounces in 1 pound. So it's just like you're dividing by 16, since it's down here. And that's an even amount, so it would just be 9 pounds. I think I need to throw my pen away. Number 5, a steel rod weighing 16 pounds, 11 ounces is cut into 3 pieces. Find the weight of each piece of the steel rod in ounces. So first, it's talking about one single steel rod, and then we're going to cut it into 3 pieces. But we're going to be answering this in ounces. So the first thing I would do is just convert all of that to ounces. So if I have 16 pounds and 11 ounces, I would want to convert this into ounces and add them together. So we know that there are, so 16 pounds. If I convert this into ounces, there's 16 ounces in 1 pound. So in this case, you're multiplying 16 times 16, right? To get 256 ounces. So you're converting the pound measurement into ounces first. And then I would need to add my 11 to it to get the total ounces, the weight of this rod, just in ounces first. So 256 plus 11 is 267. But we're going to cut this rod. So this is your rod. We're going to cut it into 3 pieces. We're saying it weighs 267 ounces. What would you do if you're going to cut that in 3 pieces? Yeah, just divide that by 3, because that's going to be your 3 pieces. I'll write the word pieces there, because we want to know the weight of each piece. So you need to distribute that weight. So 267 divided by 3 is an even 89 ounces. And they did tell you just to answer an ounce. They didn't want you to convert it or anything. They didn't ask for pounds. So each piece weighs 89 ounces. And then number 6, before we move on to the application of the other 2 types of measurements, time and capacity, I guess. A farmer has 20 tons of feed for 100 cattle. After 15 days, 5 tons of feed are left. On average, how many pounds of feed has each cow eaten per day? Just so many different parts. But first, let's think. We want to know how much each cow ate after 15 days. But we started with 20 tons and we had 5 tons left over. So how many tons were even eaten? 15. So we need to take that into account so they don't tell us that, oh, hey, by the way, really only 15 tons were eaten. So we know that 15 tons were eaten by the cows. But then it asks how many pounds of feed has each cow eaten. So what I would do is convert the total amount of feed that's been eaten into pounds. Do we have a conversion of pounds and tons? 2,000 pounds equals a ton, right? So we have 15 tons. If we convert that to pounds, one of those conversions that you see on your little sheet that you have, it's 2,000. I wrote two. 2,000 pounds are in 1 ton. So we would be taking 15 times 2,000, which would be 30,000 pounds worth of feed was eaten overall in the 15 days. So how many cows were there? 100. There were 100 cows. And so we're talking about over a 15-day period right now. We know that there were 30,000 pounds eaten by 100 cows. So each cow, how could we find out how much each cow ate over 15 days? Divided by 100. Right. We take that 30,000 pounds and we divide it by 100. So that means each cow ate 300 pounds. This one's like a 3-step process. It's pretty, or kind of 4. But they want to know per day. What would we do then? Yeah, okay. So you just kind of have to take it step by step. Sometimes it can seem overwhelming when you have so many things to do, but you can do it. So 30 divided by 15 is what? 20. So each day on average, they're saying the cows ate 20 pounds per day. They like really broke it down. Okay, so then we have a few application that have to do with your 8-3 and 8-4 staff. Remember, I kind of gave you a lecture just over how to generally convert, giving you all the conversions. It's all the same steps. If you just know the different, like 60 seconds are in a minute, or 8 ounces are in a cup kind of thing. Okay. But number 1 on this one says 5 students are going backpacking in the desert. Each student requires 5 quarts of water per day. How many gallons of water should the students take for the 3-day trip? So for everybody, right? So we're saying there's 5 students. So we need to find out how many total quarts they're going to drink to start with, I think. If you have 5 students and each of them are going to drink 5 quarts a day, I would just start with multiplying that together. So 5 times 5 means they're going to need at least 25 quarts worth of water, right? But that's actually just per day, isn't it? 5 quarts of water per day, but they're going to go on a 3-day trip. So if I were going to do total water for the 3 days, what would I do? Right. So this would be each day, and this would be for 3 days. So that'd be 75 total quarts for this trip. They're going more than one day. But then it says, how many gallons of water should the students take? So really all we need to do is just convert that quarts to gallons. So we would say 75 quarts. And if I'm going to convert that to gallons, I know that there are 4 quarts in a gallon. You could just divide by 4, you know, if you remember that there's 4 quarts in a gallon. But it would look kind of like this. And again, if WebAssign doesn't give you rounding instructions, which a lot of times they don't, and they're not asking for 2 different units in this one, are they? So kind of trying to draw attention to the differences. I would not answer it in a decimal. I mean, like this one would be an ending decimal, so I don't know, it might take it, but you would need to answer like in an improper fraction or a mixed number if you're not giving rounding instructions. So you can easily convert that in your calculator if you don't know that 0.75 is 3/4 of a gallon. You can easily convert that with your calculator, your second and the button next to your fraction key. And it would convert it to 18 3/4 of a gallon. Probably they're going to take 19 total gallons worth, right? They're going to take a little extra. But technically that's what they need and that's what they're asking because they're only wanting to know how many gallons. They didn't ask gallons and quarts. Number 2, one brand of tomato juice costs $1.59 for a quart. Another brand costs $1.25 for 24 ounces. Which is the more economical purchase? So they're in 2 different units, aren't they? So you really can't compare by just looking at their cost, what that is. Do you guys remember talking about unit pricing? A long time ago, sort of. Let's kind of go back into our brains and remember that. So one thing that we would probably need to do is convert to ounces. And so you may want to show that like you're going to take 1 quart and you need to get to ounces. And if you go back to your little sheet, we need to go back to pints and then back to cups, like work our way back up, right? So we'd say from quarts, you would need to go to pints. From pints, the next step up is cups. And from cups, the next step up would be your ounces. So you would work your way back up. I don't have my formula sheet. Well, I'll put it up there. Maybe I do somewhere. It's right here. So if I know I was given quarts right here, see how I just worked my way back up to make it to that measurement. So there are 2 pints in 1 quart. There are 2 cups in 1 pint. And there were 8 ounces in 1 cup. Remember how those things cancel diagonally. So you're really just multiplying across and you're converting a quart into ounces and it would be 32 ounces. So this is how we can do our unit costs. If you remember how to do unit costs now, this would be a little bit from that business unit a long time ago. So I could take $1.59 and divide it by 32 ounces. And I can, since this is talking about money, leave this in decimal. 1.59 divided by 32 would be like, let's take it to 3 decimal places, 0.04. I'm going to take it to 4 just because of rounding for a minute, just to compare it a little bit more. So 0.0497. So that was the first brand. The second brand was $1.25 divided by our 24 ounces. So let's go see what it would be. 125 or $1.25 divided by 24 would be 0.0521. So they're really close to the same, aren't they? If you were rounding to the nearest cent, if we were saying, just show me 2 decimals, wouldn't both of these round to like 5 cents. So they're nearly the same, but if you get really down to like unit cost, maybe you're doing these in a super bulk, wouldn't the first one technically be better, economical, because it's cheaper? So, you know, I would say the first brand is technically cheaper, but basically they are nearly the same. Pretty close to being the same. If you're going to take that to 3 digits, 3 or 4 digits for that unit pricing, then you could see a difference. Number 3, a can of apple juice contains 25 ounces. The FL is fluid ounces, by the way, contains 25 fluid ounces. Find the number of quarts of apple juice in a case of 24 cans. So if one can is 25 ounces and we're going to have 24 of them, we can find total amount of ounces by multiplying times 24. So that's going to be 600 fluid ounces. I'm just going to put ounces. So this would be like the weight of one case. That's what that means, the total weight of the whole case. But if they want to convert that to quarts for whatever reason, this is when you would get out your thing, and we're going from ounces to quarts. Okay, so you're going all the way down this list and you have these in between measurements to look at the whole way through. So I'm going to say 600 ounces. And then I know the next thing in my list is cups, right? So I'll put cups over here. And then I know the next thing is pints, going straight down the list. And then the next thing would be quarts. This is where I want to stop because that's what they asked for. So remember, like this would be ounces. You can always work your way like that too, if it helps. So how many ounces are in a cup? 8. You can get that from that list. And then how many cups are in a pint? 2. And then we have 2 pints in a quart. So it's like you're taking 600. And I just like to multiply this across. That makes it easier to simplify and see. 8 times 2 is 16, times 2 is 32. So let's look at that. Let's see what that does in our calculator. So that would represent it right now, kind of in an ugly way. 600 divided by 32. Oh, I didn't do a very good job. So it'd be like saying 75 over 4. If you turn that into a decimal, it would be an ending decimal. And so WebAssign probably would take an ending decimal because you don't round it. Or it would probably be better to just represent it or be in the habit of, if it's not a perfect number, I'm not answering this in 2 separate units, turn it into a mixed number. Make your calculator do it. You guys doing okay? Do you love conversions? If I'm honest, it makes me think a lot more than I would really like to. And there are some things I convert really often. So you just naturally do certain things in your head or you use a calculator. And yeah, you're going to do that in application purposes. It's good to kind of see all the things that can do so that you can be someone that maybe converts other things. But are you going to do it every day? I'm going to guess maybe not. But you will be able to at least refer back to something if you get to something and you're like, oh, let me help you out. I had somebody come to my house one day that is a bee farmer. So they make honey, and he needed me to help him convert some a mixture that he was making to feed them to save money overall, like economical purchase, right? So he was going to buy some things in bulk and mix it. So he came to me because he's like, I don't want to kill all my bees. You know, like that's his moneymaker. He makes a lot of honey. And so like he did it, but he was unsure because it wasn't something he does every day. So he wanted me to check his math. I mean, so it happens. It'll pop up every now and then in your life. Last one. Number 4, Nick, a mechanic, bought oil in 40-gallon containers for changing the oil in customers' cars. He paid $810 for a 40-gallon container of oil. And he charged his customers $9.35 per quart. Find the profit that Nick made on one 40-gallon container of oil. So what I would do is turn this into quarts. And then see, like, if he charged $9.35 for every quart he sold, how much would he have made? And then subtract what he paid, right? So we need to turn gallons, 40 gallons, into quarts. What did we say? How many quarts are in a gallon? 4. And it's always like, is it 4 or 2? Because in those, we do a lot of 2s, and there is a 4 that pops in on us. So really just multiplying 40 times 4. So there's he sells them with a quart's worth. That's probably measurements that you put into a car. I don't know. I am not a mechanic. Far from that. So 160 quarts worth. And he said he's going to charge $9.35 per quart. So we could say in the end, if he sold the total 160 quarts for that, like he would have taken in $14.96, but is that his profit? No, that's like how much money he collected. You would need to subtract the cost from that to figure out his profit. Some of the old unit is kind of peeking its head out on us. And he would have made $686 profit if he did that. I didn't spell profit right. There's my I. So we finished up. We spent 2 days worth, which I think is probably good. 2 days worth of lecture on unit conversions. If you haven't started your unit conversion homework, you need to. It's not due until Tuesday, but all of it. It's like 4 assignments, all due at the same time. That's because it's all very similar, right? So at first I did have them split apart where we had 2 and 2, but I'm just kind of grouping it. And it does seem like a lot, but they're not very long assignments. So you can knock it all out, but I would say don't wait till Tuesday night at 11:30 p.m. to get started. Make sure that you're doing it, do one at a time. By the time you get done with your capacities, once you get through that, then you'll be really good at it probably because you'll have all those techniques mastered. Okay. Next week we will be starting to